What is up, everybody, and welcome back to the Maths Guide. Today we have a fun lesson for us. We're going to be exploring Venn diagrams and how they're used and when we can use them. So let's waste no time, let's go. So first of all, what is a Venn diagram? Well, a Venn diagram is a way of showing data that has a relationship with each other. And the way we represent it is with these two circles. I have circle A, just here, this blue one, and I have circle B, this green one. And we can see above the circles I have titles. On the top of the blue one, I have multiples of 5. So any multiples of 5 would go in the blue circle. And then the green one is multiples of 6. So any numbers that are multiples of 6 would go in the green circle. But what you might have noticed is we have this shared area just here. This is the magic of the Venn diagram, because any relationship or any numbers that are both multiples of 5 and multiples of 6 would go in this special shared area. So let's look at this data set we have just here on the left hand side. We have numbers 5, 18, 30, 12, 15, 9 and 60, and let's decide where these go in our Venn diagram. So let's start with 5. Well, 5 is obviously a multiple of 5, but is it a multiple of 6? Well, if I go open my 5 times table, I'm not going to land on 6, so 5, 10, so no. So 5 would just go alone in the multiples of 5. What about 18? Well, is 18 a multiple of 5? 5, 10, 15, 20? No. Is it a multiple of 6? 6, 12, 18? Yes. So we would put it alone in the multiples of 6. Give that one a tick. What about 30? 30 is a multiple of 5. 5, 10, 15, 20, 25, 30. So I could put it in the multiples of 5. But it's also a multiple of 6. 6, 12, 18, 24, 30. So I could put it in here as well. But what we now know is this means it's going to live in this shared area because it has a relationship between both of our circle titles. So 30 actually lives in the shared area. What about 12? Well, 12 is not a multiple of 5, but it is a multiple of 6. So 12 would live in the multiples of 6 circle. And the same rule for 15. 15 is a multiple of 5, but it's not a multiple of 6, so it's going to live in the multiples of 5 circle. And then we get a little tricky one, 9. Well, 9 is not a multiple of 5, and it's not a multiple of 6. So can we just ignore it? Well, no, because it's a part of the data we have, so we have to acknowledge it in some way. And the way we're going to do that is we're going to stick it on its own outside the circle just here. What a loser. But we can tick him off our data. And then finally 60. Well, 60 is both a multiple of 5 and a multiple of 6. So he's going to live here in the middle with 30. And that's essentially how to create a Venn diagram using basic data like this. Let's look at a bit of a problem though. So I have a scenario here. My scenario says a class is surveyed about their favorite subjects. Their options are math and science, and students can choose one or both. And the data set shows that 10 students like maths, 12 students like science, but 5 of those students like both maths and science, and the class has 20 students in total. Now this might seem really simple. We might put our circle A as maths and our circle B as science, and we might say, well, 10 students like maths, so let's put 10 in here, 12 like science, so 12 in there, and then 5 like both maths and science. But look, we have a big problem because it says the class has a total of 20 students. And if I add 10 to 5 to 12, I end up with 27. So that's too many. So I've made a mistake somewhere. Let's have another look. Well, shows me here that 5 students like both maths and science. Well, that's a really important piece of information. And we now know that 5 is going to be in the middle because there's definitely 5 students that like maths and science. So that has to be shared. But then 10 of my students like maths. So instead of putting 10 here, I need to understand that 10 is shared between the students that only like maths, this area just here, and 5 of them that like maths and science. So I'm going to get my 10, and I'm actually going to subtract this 5, this shared 5, away from it, and that leaves me with 5. So there are actually only 5 students that only like maths. And I'm going to do the exact same rule for my science. So it says 12 students like science, but 5 of those students also like maths. So therefore 12 subtract 5 leaves me with 7 students that only liked science. Now let's check if I have my 20 total. Well, I have 5 plus 5 is 10, plus 7 is 17. So there are 3 students that are not accounted for. Well, where could they be? That's right, they could be out here outside the circles, students who don't like maths or science. And that gives me my total of 20 students. Tick. You have a go. This is another scenario. This scenario says a survey is conducted among students to find out their preferred after-school activities. The options are sport and music, and students can choose one or both. The data shows 15 students like sports, 12 students like music, 6 students like both music and sport. The total number is 20 again. So, using your own Venn diagram, can you put this data into the correct sections of your Venn diagram? Have a go at answering this and then put your answers in the comment section. I'm going to do my best to mark every single one. Have a go, press pause, good luck. And that's it. That is how to use a Venn diagram and what a Venn diagram looks like. Hopefully this video was helpful for you. If it was, head on over to themathshelter.com where you're going to find loads more videos to help you with everything you need to know about maths. But for now, guys, see you in another video. Peace out.